Let's discuss the distance form of a line. The equation of a straight line that passes through the point having the coordinates x1, y1 and making an angle of theta with the positive direction of x-axis. This equation is given by x minus x1 divided by cosine of theta equals to y minus y1 over sine theta. That's equals to r. And here r is the distance between the points x1, y1 and x, y. Okay, so we'll try to derive this equation. First, let's try to understand it graphically. So here we have the xy coordinate system and we have a line L. The line L is drawn in such a way such that, let's say, it passes through the point P. And let's say the point P has got the coordinates x1, y1. And then this particular line is going to make an angle theta with the positive direction of x-axis. Now what we'll do, in order to derive the equation of this line, we're going to consider, let's say, another point Q. Now let's say Q has got the coordinates x, y. Now that is going to be the locus of the line. Okay. Now in order to derive the equation, what we'll do, we're going to drop two perpendiculars from each of the 2 points P and Q on the x-axis. Now let's say the perpendicular drawn from the point P meets the x-axis at the point M, and perpendicular drawn from the point Q meets the x-axis at N. Okay, then what we'll do, we're going to drop a perpendicular from P on QN as well. Let us suppose that the perpendicular meets QN at the point, let's call it R. Okay, now we can now easily define the distance PR as well as QR. Now PR, this length, this is simply going to be it's going to be x minus x1, and then we have QR, so this is going to be y minus y1. Fine. Now if this angle is theta, then definitely this angle is also going to be theta. That means QPR, that's also going to be the angle theta. Let's consider the triangle PRQ, which is right angled at R. Here what we'll do, we're going to take cosine of the angle theta. Now cosine of the angle theta, this is simply going to be the adjacent to that of the hypotenuse. So our adjacent, that's PR. So we have PR divided by the hypotenuse, which is PQ. And if we have sine of theta, so sine of theta, that's going to be the opposite. So the opposite, that is going to be QR divided by the hypotenuse, which is PQ. Now here, PQ, that's the distance between the points P and Q. So let us suppose that PQ, let's say that's equals to R. What we have here is cosine of theta, so that is going to be equals to PR. So what is PR here? PR is simply going to be x minus x1 divided by R. And then sine theta, that is going to be equals to y minus y1, so that's QR divided by PQ, so that's going to be R. So we have R equals to x minus x1 divided by R, and R is going to be also equals to y minus y1 divided by sine theta. So when we combine them, then we are going to get x minus x1 divided by, this is cosine of theta actually, not R. But we have x minus x1 over cosine of theta, that's going to be equals to y minus y1 divided by sine theta, and both of them are equals to R. And this is the required equation of the line. Okay, and this is referred to as the distance form of a line. This is the distance form of a line. Okay, now there is also a easier way to remember this formula if we don't want to go through the process of deriving it over and over again. Remember the slope point form of a line. The slope point, or you can say the point slope form of a line, is given by y minus y1 equals to the slope m times x minus x1. So that means if we have a line that passes through the point x1, y1, and we know the slope of that line, that is going to be given by y minus y1 equals to m. M here is the slope times x minus xy. Now we know that the slope is defined as tangent of the angle that the line makes with the positive x-axis. So we have tangent of theta times x minus x1. And what we can do, we can convert tangent of theta to sine theta over cosine of theta and rewrite it, and that is going to give us this particular equation. All we have to remember that the two ratios are equal to each other and both of them are equals to the distance between the 2 points P and Q given by R. Okay. So this is referred to as the distance form of a line. Furthermore, what we can do here is we can also consider x minus x1 divided by cosine of theta. That is going to be equals to r. So we have x minus x1 equals to r cosine theta, or we get x equals to x1 added to r cosine theta. Similarly, we have y minus y1 divided by sine theta. So that is going to be equals to r. So we have y minus y1 equals to r sine theta, or we can say that y equals to y1 plus r sine theta. Fine. Now, since r is a variable here, that is the distance between the points points P and Q. That means this r, depending upon the value of r, x and y are going to change. So we can say here that these are the parametric form of the points lying on the line. So here we can say, since x and y are also the coordinates of the point Q, so point Q has got the coordinates x comma y. So this simply also means that the coordinates can be represented in its parametric form as x1 added to r cosine theta, comma y1 added to r sine theta. Now, there is a certain advantage of writing the coordinates of point Q in its parametric form. This simply means that, let's say we have, this is our x and the y coordinate forming the xy coordinate plane. So let's say we have a straight line. We're just considering a random straight line. Let's call it L prime. We want to determine the coordinates of, let's say, this point A. Well, let's call it x comma y. We want to determine the coordinates of this point A. If we have the information, that means if we know that this line is going to also pass to another point whose coordinates are known, that means x1 comma y1, that is known, and we also know the angle that it makes with the positive direction of x-axis, then we can define the coordinates of that point, that means coordinates of the point x comma y, using this parametric form. Also, while deriving the parametric form of the coordinates of point Q, here we consider the fact that the point Q lies to the right of the point P. That means x comma y, this coordinate point lies to the right of x1 comma y1. Then in that case, we're going to get the coordinate of x as x1 plus r cosine theta, and the y coordinate is y1 plus r sine theta. However, if our point Q lies to the left of the point P, then in that case, then we were going to get x1 minus r cosine theta and y1 minus r sine theta. So we'll make use of this accordingly.